Welcome to The Explainer. We're going to tackle a concept today that you probably ran into back in physics class, potential energy. But here's the thing. We're going to look at one simple little idea about it that might just flip everything you thought you knew on its head.
All right, so let's just jump right in with a super simple scenario. Picture this. You drop a basketball. As it falls, it picks up speed, right? It goes faster and faster. That means its energy of motion, what we call its kinetic energy, is going up. But, and this is a big but, one of the most fundamental laws of physics is that you can't just create energy out of nothing. So, if the ball is gaining all this motion energy, where in the world is it coming from? Now, the most intuitive answer, the one that probably pops into your head first, is that the energy was already stored inside the ball when you were holding it up high. We give this a name, right? We call it potential energy. It's literally the potential for that stored energy to turn into something else, like motion. You can almost think of it like the ball has a little battery inside that discharges as it falls. It's a really neat and tidy idea, but yeah, there's a huge flaw in thinking about it that way. And to see what that flaw is, all we need is a quick little thought experiment. And trust me, this is going to completely change how you think about where this energy actually lives. Okay, so let's do it. Imagine our basketball, but instead of being in your hand, it's just floating all alone in the total emptiness of space. And now for the weird part. What if we could just, poof, make the Earth disappear? Well, without the Earth, there's no gravity to pull on the ball, right? So it just floats. It's not going to fall, it's not going to speed up, and it's certainly not going to gain any kinetic energy. And just like that, all that potential energy it was supposed to have, it's just gone. This reveals something incredibly important. So here's the big takeaway, the absolute key idea. Potential energy isn't something a single object has. It's not in the basketball. It's actually a shared property. It exists in the interaction between the Earth and the ball. It belongs to the whole Earth-ball system. See, the energy is stored in the relationship, in the space between them, not inside one of the objects. Okay, so if potential energy belongs to a system, what exactly about that system holds the energy? It actually all boils down to one simple, elegant word: arrangement. So let's get a better definition on the table. Potential energy is simply the energy a system has because of the way its parts are positioned or arranged relative to each other. That's it. When you lift the basketball away from the Earth, you're changing the arrangement of the Earth ball system, and that's what stores the energy. And this comparison here just nails the core difference. Kinetic energy, that's the energy of motion. It's all about speed. But potential energy, that's the energy of arrangement. It's all about position. So you can really think of it this way. One is about moving, and the other is about placing. Simple as that. And, this whole energy of arrangement idea isn't just a gravity thing. Not at all. The exact same principle is at play with other fundamental forces. You arrange positive and negative charges in a certain way, boom, you get electric potential energy. You arrange the tiny particles inside an atom's nucleus, that's nuclear potential energy. It's a totally universal concept. All right, so let's dig a little deeper into how this energy actually behaves. Does it go up or down when things start moving around? Well, it turns out it all depends on whether the forces are attractive, pulling things together like gravity, or repulsive, pushing them apart. This table here really shows what I like to call the dance between kinetic and potential energy. Think about it. With an attractive force like gravity, what do objects naturally want to do? They want to move closer. And when they do, they speed up. So kinetic energy goes up. But since energy has to be conserved, that means potential energy must go down. Now, for repulsive forces, like two positive charges trying to get away from each other, it's the complete opposite. They speed up as they fly apart, so potential energy drops as the distance increases. And this whole relationship, this back and forth, leads us to one of the absolute weirdest sounding ideas in all of physics, and that's the idea of negative energy. I know, it sounds like something straight out of sci-fi, but it's a totally real and direct consequence of how potential energy works. So here's the secret to understanding this. In physics, the actual number you assign to potential energy, it doesn't really matter. What matters, the only thing that has any physical meaning, is the change in potential energy. Just look at these two scenarios. In scenario A, we go from 100 down to 0. The change is minus 100. In scenario B, we go from 0 down to negative 100. The change is still minus 100. The physics is exactly the same because the energy drop is the same. And because only the change matters, that gives us an incredible freedom. It means we get to choose wherever we want our 0 point to be. We can pick any arrangement, any position, and just decide, yep, that's zero. It's a choice we make purely for convenience, to make the math easier. So for example, if we're just talking about stuff here near the Earth's surface, it makes total sense to call the ground zero. Super convenient. But when physicists talk about planets and stars, they actually set the 0 point when the objects are infinitely far apart. So since gravity pulls them together and reduces their potential energy from that 0 point, pretty much any real-world orbital system has negative potential energy. It's the same deal with electric charges. And negative potential energy is just a shortcut to tell you that the force between them is attractive. It's a really clever convention. So, okay, we've gone all the way from a simple falling basketball to negative energy out in space. But why does any of this really matter? Why should you care? Well, because once you really get this idea of energy of arrangement, you start to see it hidden absolutely everywhere. It turns out that so many other types of energy we talk about are actually just potential energy in disguise. Think about elastic energy. When you draw back a bowstring, what are you doing? You're just changing the arrangement of the atoms in the bow, storing electric potential energy between them. Or what about the chemical energy in fuel, like gasoline? That's nothing more than the potential energy stored in the specific arrangement of molecules and electrons. A chemical reaction is just the system rearranging itself into a lower energy state and releasing the difference. And that really brings us to our final and maybe the most profound takeaway here. Potential energy isn't just some boring textbook concept for figuring out how fast a ball is going to fall. No way. It's a deep, fundamental principle about how energy is stored in the very fabric of our universe, in everything from planets orbiting stars to the fuel that powers our cars. And so that leaves us with one last question to chew on. If so much of our world is governed by the arrangement of tiny particles, what else out there is just stored potential, just waiting for the right moment to be released?